Welcome to ee6083, Aviation Standards Software Design and Certification. This is Module 1, the Introduction. For all the modules that in this course, one of the first slides will be the study material. So at the top it actually will have the relevant chapters or sections out of the textbook, which is Developing Safety Critical Software, a practical guide for aviation software and DO178C compliance. And underneath it will be some other references, and some of these references will be available to you via Blackboard. What we'll be making use a lot in this course of definitions. Definitions are used quite extensively in standards, requirements, and specifications for the simple reasons that for all the people that want to use a standard or requirements document, they have to have the same jargon. They need to use the same jargon, the same nomenclature. So then everybody can talk to everybody and everybody knows what everybody else means. At least all the users of these standards or requirements documents. This course will spend a lot of time on software for safety critical systems. So the first thing we're going to do is talk a little bit about safety. Now, you can actually go to the Webster's dictionary or any other dictionary and find some definition for safety. But within the context of this class, we're really going to define safety with respect to human life, property, or the environment. So it's not only that human life is being affected, in other words, people get hurt or die, but also is that there may be some damage to property or even damage to the environment, so impact to the environment. Okay? So it's not just about human life, it also involves some economical value of property and the environment, of course. Now, specifically, we're going to talk a lot about safety in this course. So when we talk about software safety, a typical definition is that it's the features and procedures and functions that make sure that a software product performs predictable on both normal circumstances but also under abnormal conditions. The conditions are not always regular normal. In some cases, something weird happens that causes abnormal conditions at the input of the software. The software still needs to be able to continue operation in a predictable fashion if that happens. What we achieve by actually adding these features and procedures is that we reduce the likelihood of an unplanned event. And as a result, reduce the accident rate, the chance of an accident. A couple of definitions. I'm going to just mainly talk about the first three, then I'll go back to the hazard and accidents later. By an error, I really mean a deviation from the desired or intended state or operation of a system. In this case, an example would be a software bug. A software bug, maybe there's an equation that you have implemented wrong inside the software, causes the system to not output exactly what's desired, but maybe something slightly different. So it also means that these errors not always manifest themselves. They may only manifest themselves under a certain set of input conditions. And when that happens, we refer to it as a fault. Finally, we talk about a failure. And a failure is more at the system level. Now, when we define a system in systems engineering, we talk a lot of times about what it is that the system needs to be able to do. In other words, its intended function. Inability of the system to perform this intended function is what I refer to as failure. So if you look at the typical accident model, you see that an error may manifest itself, then turn into a fault. This fault may potentially lead to a failure, and then, given the right circumstances, this failure will become a hazard. And by hazard, I mean that given the environment or the operational scenario of the system, that causes a failure to result in a hazardous situation. For example, if I drive on a highway and there's no traffic around and my brakes fail, I can roll out and there's never a hazardous situation. However, if I'm on a highway and it's very dense, there's dense traffic, now when my brakes fail, there's a high probability of me actually getting into an accident. So the external environment's conditions determine if the situation is hazardous or not. Then when there is a hazard, it may also mean in some cases that it could result in an accident. In other words, I refer to it as a loss event. There's a certain amount of loss with respect to human life, the environment, or property. So again, come back to the error, fault, failure. Failure may turn into a hazardous situation, and that may lead to an accident. In the software assurance standards that we're going to talk about in this course, you see actually this particular picture. In this case, you see that same relationship. You see there may be some bug, some latent error in the software. You won't see them until the conditions are right, in what case the software bug may manifest itself and cause a fault. And then given the right conditions again, in the system level right conditions, this may result in the fact that the system can no longer perform its intended function. In other words, there'll be system failure. Then given the right conditions, or the wrong conditions in reality, in the environment, this may mean that it can actually be a hazardous situation. Now, one thing if you talk about hazards is, there's two things associated to hazards. On one hand, you have the severity level. On the other hand, you have the likelihood. The table that you see here is really comes from Advisory Circular 23-1309, which in the columns show you the severity level, in other words, always with no effect, to catastrophic, and in the rows it shows you the effect on the airplane occupants and flight crew. And you see is under the severity column no effect, you see there's no effect on all three of them, whereas in the most stringent one, the catastrophic category, what you see is that it means that you're going to lose the airplane. And multiple people may die, or the crew may be incapacitated. So you see it gets all the way from no problem to really bad. And one thing is to see that for aircraft there's a different effect on the occupants and flight crew, and that's because the flight crew is considered trained. Now typically if the severity level is very high, in other words, if a failure occurs and this failure may lead to a catastrophic error, what we like to do is we want to make sure that the probability that failure happens is of course very small, has a small likelihood. Whereas if the failure has no effect, that means that the severity level is with no effect, means the probability can be fairly high. So you see it here. Typically, we express those in probable, remote, extremely remote, extremely improbable. And you see that typically are associated with numbers. Okay, so recap, hazards of both the severity level and the likelihood associated with it. Well, this table comes directly from one of the FAA documents. This kind of relates these probabilities in actual numbers to the severity levels, the failure conditions, as well as the software levels, which we'll talk about later. Finally, one thing you have to realize is that when we talk about a probability of 10 to the minus 9 per flight hour, this means that the chances of a failure happening in a flight hour is 1 in a billion. That means if you would have to test it just by flying it around, you have to fly around for 1 billion hours or 11.415 years. So this is really complicated. This is going to be tough to do.